Dear 4th grade students at the Department of Economics, this is our second recorded lecture for the module entitled Econometrics. I very much hope that you are all in the best of your states. If you have any questions, please don't hesitate to contact me. The current presentation mainly discusses hypothesis testing in the context of two-variable regression. The main source is Chapter 5 of Gujarati 2004. As you already know, estimation and hypothesis testing constitute the two key branches of classical statistics. The point estimation has been discussed in the previous lectures, in which the OLS method of point estimation has been introduced. In the current presentation, hypothesis testing for the OLS coefficients is to be discussed, but hypothesis testing involving the coefficient of determination is to be introduced in the next lecture, along with a test of model adequacy, that is the normality test of the error term. Testing for the normality assumption is quite important because in small samples the T, F, and the chi-square tests require the normality assumption. Bear in mind that there are some statistical prerequisites for testing statistical hypotheses. I know that you are familiar with the fundamental concepts of probability and statistics. Appendix A of Chapter 5 provides the essentials of statistics. Key concepts include type 1 error, type 2 error, level of significance, power of a statistical test, etc. These concepts are of crucial importance for understanding the issues covered in the current chapter and the following chapters. The essence of econometrics is to quantify economic relationships. This is done by analyzing sample data and asking what conclusions we can draw from this quantification. Hypothesis testing goes beyond computing estimates of the true population parameters to a much more complex set of questions. There are two main questions. First, is it likely that our results could have been generated by chance? Second, would the results obtained from the employed sample lead us to reject our original theories? Generally, the hypothesis testing procedure includes 5 steps. These steps are to set the null and alternative hypothesis. Second, to determine the level of significance. Third, to identify the test statistic. Fourth, to determine the decision rule. And finally, to make the decision whether to reject the null hypothesis. These steps are briefly discussed in the next slides. The first step of the 5-step hypothesis testing procedure is to state the null and alternative hypothesis. So, what is the null hypothesis? And what is the alternative hypothesis? The null hypothesis could be defined as a statement of the values that we don't expect. It could be described as the no difference hypothesis. This because the estimated coefficient is assumed not to be different from a certain given value, say for example 0 or 1. On the other hand, the alternative hypothesis is a statement of the values that we expect. In a clear-cut definition, an alternative hypothesis could be defined as any hypothesis or statement that contradicts the null hypothesis. Let's have some examples to illustrate the null and alternative hypothesis. I mean how to formulate both of them. Assume that we expect that the slope coefficient of a simple regression to be just different from 0. In such a case, we perform a two-tailed test in which the alternative hypothesis has values in both sides of the null hypothesis. But if we expect this slope coefficient to be positive, then we perform a one-tailed test in which the alternative hypothesis has values on the right or the positive tail of the null hypothesis. Similarly, if we expect that the slope coefficient to be negative, therefore we conduct a one-tailed test in which the alternative hypothesis has values only in the left or negative tail of the null hypothesis. The second step of hypothesis testing procedure is to determine the level of significance. That is the probability of committing type 1 error. Errors can occur when making inferences from samples. Why? This is because the typical hypothesis testing procedure involves hypothesizing an expected sign or value for the slope coefficient or for each partial slope coefficient. In the case of multiple regression, we will see that later. Then, this procedure proceeds to determine whether to reject the null hypothesis or not. Recall that the regression coefficients are only estimates of the true but unknown population parameters. Therefore, it would not be reasonable to think that conclusions drawn from regression analysis using samples are always right. There are two types of inference errors, that is type 1 error and type 2 error. In type 1 error, we reject a true null hypothesis, whereas in the type 2 error, we do not reject a false null hypothesis. Type 1 errors may involve concluding that there is a relationship between the dependent and independent variables when actually there is no relationship between them. A type 2 error involves the opposite occurring when we conclude that the two variables are not correlated when in reality they are. Type 1 error is also known as the level of significance, as I just mentioned earlier. It is represented by the Greek symbol alpha. Conventional levels of significance are 1%, 5%, and 10%. For instance, 5% level of significance means that we are willing to take risk being wrong 5 times out of 100 times when rejecting the null hypothesis. The third step of hypothesis testing procedure is to identify the test statistic. The t-test is used to perform hypotheses relating to individual regression coefficients. The t-statistic is the proper test to use when the stochastic or error term follows a normal distribution and when the variance of the distribution must be estimated. The t-statistic for an individual regression coefficient is computed by dividing the difference between the actual value of the sample regression coefficient and the hypothesized value by the standard error of this coefficient. Therefore, it could be calculated for the intercept and the slope coefficient are as shown by equations 1 and 2 respectively. The fourth step of the hypothesis testing procedure is to determine the decision rule. It typically involves the comparison between a sample statistic with a pre-selected critical value that found in the statistical table. For the OLS regression coefficients, we use the student T table. The pre-selected critical value divides the sampling distribution with respect to the null hypothesis into two areas. That is an acceptance area and a rejection area. The critical value depends on the degrees of freedom, the level of significance, and whether we use one-tailed test or two-tailed test. In the current case, the degrees of freedom is computed as the difference between the sample size and the number of estimated coefficients. Since we study the simple regression analysis, the degrees of freedom always equals n-2 or the number of observations minus 2. Table 5.1 summarizes the decision rule for the t-test of significance. Instead of using the student t statistical table to find the critical values for decision rule purposes, there is another approach that depends on using p-values of a reported t-statistic. This approach has become very popular given that all econometric software packages report t-statistics for the estimated regression coefficients and their p-values. This p-value is also known as the marginal significance level. Its value ranges between 0 and 1. Given a p-value, we can at a glance decide whether to reject or not reject the null hypothesis that the true value of a regression coefficient is 0 against a two-tailed alternative that it differs from 0. If the p-value of a computed t-statistic is less than the predetermined level of significance, reject the null hypothesis that the coefficient of interest equals 0. The last step of the hypothesis testing procedure is the decision making. In this step, we compute the value of the t-statistics of regression coefficients. Then we compare them with the corresponding critical values at the pre-specified level of significance to arrive at a decision. The alternative approach is to compute the p-values for t-statistics for regression coefficients and then compare these p-values with the predetermined level of significance. Remember that the level of significance is determined in step 2. After performing this comparison, we make the decision whether to reject the null or not. Finally, we explain the implications of our conclusions. Now let's have a numerical example for hypothesis testing for the OLS regression coefficients. Recall that in the previous lecture we interpreted the meaning of the intercept and slope coefficients for a simple regression model in which we used the OLS method to quantify the relationship between weekly income and weekly consumption expenditure for a sample of 10 families. The obtained results are shown below. The value of the slope coefficient is 0.509. So the question is, does this agree with our prior theoretical expectations? For example, the economic theory states that income and consumption are positively linked. So let's formally test this hypothesis. To formally test that the weekly consumption expenditure and weekly income are positively related, we adopted the 5-step hypothesis testing procedure as follows. In step 1, we formulate a one-tailed test in which the alternative hypothesis has values in the right or the positive tail of the null hypothesis. In other words, the null hypothesis states that weekly income doesn't influence the weekly consumption expenditure, or this income negatively influences it. In contrast, the alternative hypothesis states that weekly income positively influences weekly consumption expenditure. That is to say, an increase in weekly income causes increase in weekly consumption expenditure. In step 2, we determine the level of significance to be 5%. In step 3, we identify the test statistic to be t-test as shown. For step 4, we have to determine when to reject the null. If the t calculated for the slope coefficient is greater than its corresponding critical value at the pre-specified level of significance, we have to reject the null. As shown in figure 1, the critical value divides the sampling distribution with respect to the null hypothesis into two areas, an acceptance area and a rejection area. It is clear that in such a one-tailed test, the alternative hypothesis has values in the positive tail of the null hypothesis. Finally, in step 5, we have to make the decision. So we compute the test statistic. Its value equals 14.5. Then we compare it with its corresponding critical value, that is 1.86. Given that calculated t-statistic for the slope coefficient is greater than its corresponding critical value at 5% level of significance, we reject the null. Thus, we conclude that weekly income positively influences weekly consumption expenditure. In other words, if the real weekly income increases by $1, then the real weekly consumption expenditure increases on average by 51 cents. Such a conclusion agrees with prior expectation. Now, it's your turn to employ the 5-step hypothesis testing technique to test whether the slope coefficient is less than 1. Again, apply the same technique to test whether the intercept coefficient is different from 0. Here, we are going to employ the p-value approach to test for the significance of the OLS regression coefficients. Screenshot 1 shows the OLS estimates for the relationship between the expenditure on food and the total expenditure of a sample of 55 Indian households in the year 1994. Both variables are measured in thousands of rupees. It is worth mentioning that the total expenditure is used as a proxy for income. Of interest to us is the middle section of this screenshot. It provides the estimated values for the intercept, slope coefficient, their estimated standard errors, their computed t-statistics, and their accompanying p-values. At the first glance, we could say that the slope coefficient is significantly different from 0 beyond 1% level of significance. In contrast, at the exact level of significance of 0.069, we could say that the intercept is not different from 0. Now, it is the end of our recorded lecture. I would say it again. If you have any questions, please don't hesitate to contact me. Thank you so much.